Procedure we were giving was a matched pairs t-test. The question we were addressing is, does hand dominance make a difference in accuracy? We were testing this by seeing if people are better at putting with their dominant or less dominant hand.
Our HO is that there's no difference between dominant and non-dominant hands and their accuracy, and then our HA was that there is a difference between dominant and non-dominant hands and their accuracy.
We then checked our assumptions to make sure we could proceed. First, we checked normality, since we had 30 participants, CLT applied. We knew our sample was random because we randomly assigned people to putt with their dominant or non-dominant hand first by flipping a coin. And lastly, we assume independence because each participant's putts are different from one another. A possible lurking variable may be if the participant has golfed or not in the past. We measured how far the golf ball was for each putt in centimeters. In order to continue with the matched pairs t-test, we use the equation t equals x bar minus mu over the standard deviation divided by the square root of n. We then ran a t-test on our calculator and found out that our p-value was 0.3537. However, because it is a matched pairs t-test, we divided it by 2 and got 0.1769. With this p-value, we compared it to the alpha level of 0.1 and saw that we needed to fail to reject HO. With statistical evidence, we can conclude that when we fail to reject HO, this means